what are functions? Functions are another way to represent y. So y equals to f of x. But what does this mean? Right? What does it mean? So let's take a different, let's write a graph here, alright? X equals plus 4. So the equals plus 4. So perhaps that looks appropriate. So we have a straight line graph here. When we look at this graph, which values do we have control over? Y or x? We have control over x, right? Because we can't really control y, because y is basically the output. So when you input a value of x over here, you'll get this value of y. And when you input a value of x over here, you get this value of y. So x is your input and y would be your output. But now let's say we give a value, right? So perhaps we do 2 and 4. 2 and 4, so it'll be 6 here and it'll be 8 over here. So we can write y equals to 2 plus 4, 6, and y equals to 4 plus 4 equals 8. So this is basically the x, this is basically the x. Now when we look at these two, it's not very clear, like why does y have two different values? And we can only write this when we write when x equals to 2 or when x equals to 4. We can do it like that, or we can just represent y with a function. So in a function, we write it as f of x equals to x plus 4. And just a note, this letter here is not algebra. So you can't take f of x. So let's put this at the side. Can't take f of x, y, and then just make it like this. No such thing. This is impossible. This is completely wrong. F of x is just a way to represent that you want to put a certain input. So this is your input, or to make things more clear, it is your when x equals. So this is when x equals. So if we have f2, it will be 2 plus 4. So this was x previously. If we have f4, it will be 4 plus 4, and this will be your x. So I hope now you understand what functions are. It's a very similar concept. It's basically input and output. Very simple. So output and output. So in a graph, instead of y, you can represent it as f of x over here, and x. F of x and x. Next, what are domains and ranges? So the best way for me to explain this would be with a quadratic function. That's the most commonly used function in this module. Oops, that's not the line I was looking for. Not that either. There. Nice. Not so symmetrical, but no need to be so nitpicky about it. Okay. So we have a quadratic function. So this quadratic function, let's get used to representing as f of x instead of y. So this quadratic function will be a simple f of x equals to x squared. Now when we look at this function, I want you to ask yourself, what possible values of x are there? And what possible values of y are there? So remember that y equals f of x, alright? The possible values can be looked with this graph. So we know that this quadratic graph over here is just going to keep growing. It's just going to grow and grow and grow and grow. It's just going to keep on growing and growing. So when we look at it, this is going to infinity, and this is going to infinity. But you see, this is going in a diagonal. They're both going in diagonal directions. All right. Well, they're actually curved, so they're not straight lines, but they're going in a diagonal direction. So let's break it into horizontal and vertical. All right. So if we break this, it would be going this way. This one, ooh, why am I suddenly highlighting? This one would be going this way. And then if you look at this way, so y-axis going this way, and this one is going this way. Alright, so red is going to infinity, this one is going to negative infinity, because you know over here would be over here is the negative, this is the negative portion already, this is negative already. So here it will be going to infinity, here it will be going to infinity. So a domain and a range is basically a mean to represent this set of values that are possible for the function. So the possible x values would be minus infinity to infinity, right? So the way to represent this would be with set builder notation. So in set builder notation, you write curly brackets first, you write the variable you're dealing with, a straight line, and then the set of values. So let's take x for example. If you're doing x, we write the variable x, write line, and then put negative infinity, and then x, then infinity. Okay. But now we look at the f of x value. Is f of x the same? I don't think so. F of x, looking at it, it actually stops over here. So how would we represent it? We would actually represent it as set builder, so your curly brackets, f of x, a slash, f of x more than or equals to 0. So maybe you're wondering why it's not the same. Why is it not the same as x? Let's just look at the function itself. So let's take 3 different cases. 0, so f of 0 equals 0 squared. f2, 2 squared. f minus 2, minus 2 squared. 0, 4, 4. So we took 2. This is 4. We took negative 2. Also 4. So you see that no matter what value of x you put, the y is going to return a positive value. Because anything you square would be a positive value. So even if you go negative 900 squared, it will still be a positive value. And you know, it really does not matter how big. So the only possible value of y is zero. Because when I put f of 0 equals 0 squared, then it equals 0. That's why it stops here at x equals 0 and y equals 0. So the coordinates here is 0, 0. So that is what domains and ranges are. And just a point to note, this control over the limit, right, can be controlled by conditions that you want to put. So it doesn't necessarily always have to be negative infinity to infinity for a quadratic function. But if you're given a quadratic function, and the question asks, what is the domain and what's the range, then yes, you will stick to this kind. But there will be certain kind of special questions. Which will seek domain and range which is controlled by you.